Hello, I'm going to do an example here from 5.2, the method of elimination. Okay, so here's our system. Okay, so let's suppose that we know that our x prime plus, let's see, what do we have here? Plus 2y prime. We want this to be equal to 4x plus 5y. And then we want 2x prime minus y prime. We need that to be equal to 3x. We have an initial conditions here. We want x at time 0 to be equal to 1 and y at time 0 to be equal to minus 1. Okay, so here we go. What we're going to do is we are going to try to eliminate essentially one of these derivatives. So what I'll do here, let's call this equation number 1, and this is equation number 2. Okay, so draw this line here. All right. So if we take a look at 2 times equation 1, and if we subtract equation 2, let's see what we get. Well, let's see. You get 2 times x1. See, that's going to get rid of the x prime here. So we're just going to be left with 5 y prime. We get a new equation. That is going to be equal to, see, 2 times 4x, it's 8x minus 3 is 5x. And then we're left with our 10y here. Okay. So the idea of this technique, well, what I'm going to do here is I'm now going to solve this equation for x, and then you see I'll be able to find the derivative of x in terms of y. Okay. So if I solve this equation here for x, I get that x is equal to what? Well, let's see. We got just y prime minus 2y. Okay, now if I differentiate this, I get that x prime is equal to y double prime minus 2y prime. And now what I can do is I can substitute this into equation number 1. Okay, see if I use these 2 expressions for x and substitute those into equation number 1 here, you see I will have a new equation where we won't see x. Then we'll use our old techniques, and you can I'll do that. So watch what we get. Okay, so we get okay, from equation 1 I'm seeing we get y double prime minus 2y prime plus, you see that's x prime, right? Now you get 2 times y prime. So that's 2 times, well, just y prime, we leave that alone. And that must be equal to, now we have to take 4 times x, so that's going to be 4 times x, which is now, we want to think of that as y prime minus 2y. And then we would like to add 5y. Whoops, sorry about that. Then we want to add 5y. Okay. Now if you simplify this equation or solve for 0, then we see we get our friend here. We get y double prime minus 4y prime plus 3y is equal to 0. Okay, and now we use our techniques that we've learned. We can look at the characteristic equation is r squared minus 4r plus 3 equals 0. And this factors nicely. So we get r, what is it, r minus 3 and r minus 1. So we see that our general solution to this differential equation is, so we get y of t is going to be some constant c0 times e to the 3t plus another constant c1 e to the t. Okay. Now we need an expression for x also, and you see that comes from this. Okay, so that will come from this equation right here. So as we know, x is y prime minus 2y. So all I need to do here is find out what the derivative is. So y prime of t is 3c0 e to the 3t plus, oops, c1 e to the t. Notice that I use the same constant here. That's not a good thing. So let me go in here and fix that. This 0, this should be a 1 to indicate it's a different constant. Okay, okay. Now we want to find out what our constants are by using our initial conditions. So our initial conditions are that we want x at time 0 to be 1 and y at time 0 to be minus 1. Well, first let's find out what x is using this equation. So x is y prime minus 2y. So here we go. So x at time t would be equal to, let's see, it's going to be, what did I say that was? I'm sorry, I'll look back up here. So let's see, x at time t is, where is that? Okay, so that's y prime minus 2y. So it's 3c0 e to the 3t plus c1 e to the t, and then it's minus 2 times y, which is just c0 e to the 3t plus c1 e to the t. All right. That simplifies to the following expression, that x at time t is actually just equal to what? Okay, we get, oh, I'm sorry, just I keep hitting the wrong button here. So we get c0 e to the 3t, that's 3 minus 2, and then we get minus c1 e to the t. Okay, so now plugging in our conditions here, we'll put t equals 0. For x we get 1, okay. So here we go, watch this. X at time 0 turns out to be, it is just c0 minus c1, and that we want to be equal to 1, okay, as our initial condition here. And we get the following fact, that we want y at time 0, we know, is equal to, let's see, what do I get here? Well, y at time t is just, okay, c0 e to the 3t, c1 e to the t, so I get c0 plus c1 equals minus 1, okay? So from this, we see that the solution, well, you can, here's a system of equations, but you can kind of see it, that see, c0 in this case would be equal to 0, and c1 is equal to minus 1. Okay, so now we can write down our solutions. You see, that means that y at time t, if you plug in the conditions, okay, see what it is, minus, so y at time t is just equal to, well, here, it's going to be, well, generally speaking, it's C0 e to the 3t plus C1 e to the t. So using our conditions, we see that that's just going to be equal to minus e to the t. And looking at x, you see that x at time t is equal to just e to the t. Okay, so that's how we do these problems. There's a couple there. And in the next section, we'll start to move into a more general approach to these types of problems. So thank you.